Okay, now let's talk about number 4 on the back page. And a motorboat is traveling on the Mississippi River. The boat travels at 20 miles per hour in still water. Still water means there is no current, okay? Just like lake. The boat went 6 miles down river with the current in the same amount of the time. It took the boat to travel 5 miles upstream against the current. So downstream, let's look at the given information here. The rate is downstream 20 plus C. Where is C from? C is for the speed of the current, okay? So how fast is the current? So that is going to be the speed of the current. So let's say, oh yeah, they used C, right? So let me use C instead of X. So 20 plus C, down, 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 it is easy. You got free little speed, right? Because of the river flows, okay? So 20 plus C. Upstream, going backwards, if you don't have engine, it will be really tough going backwards, right? So think about that, and then we will get smaller number on the speed. That means we are getting slowly, right? So 20 subtract C, the current, and then we are going upwards, okay? So by knowing that, and we will use the condition, we have the same amount of time, so we will set up an equation. Equation for downstream is 6 miles divided by 20 plus C as a rate. So time formula is distance divided by rate, right? So we are using that. On the right hand side, I have 5 miles, and the speed gets smaller because we are moving against the current. So that is the equation we need to solve. Does it make sense? And then put extra parentheses for grouping the binomials, and then use cross multiplication. Cross multiply. So 120 minus 6C equals to 100 plus 5C. And add the C on both sides, or let's move the terms to the other side, and that's going to be 11C one side, and move the term, and then we have a 20 as number, right? So how do we get C? Divide both sides by this, and that will be the answer, right? Since this is kind of a real life problem, let's have answer in decimals. What is approximation? 1.8. Okay, so let's go with 1.8. What is the unit for this answer? Miles per hour. Okay, miles per hour. Question number 5. 2 planes left from Nashville at the same rate of speed. This time we have the same rate of speed. Rate of speed is the same. The first plane flew to Boston for a total of 1,100 miles. The second plane flew to Milwaukee for a total of 600 miles. Okay, so drawing here. It took the first plane flying to Boston an hour longer to reach its destination. How long? So this how long doesn't mean distance, okay? How long did it take the second plane to travel to Milwaukee? So we are looking for the time, okay? So let's set it up. So in the equation, I need to use same rate of speed. How do we find the rate? What's the formula for the rate? Distance divided by time. That's right. So let's have that on the left and right, so we can have a ratio, and let's set it up as an equation, which is the proportion, okay? So we'll have a denominator unknown, that is a rational function. So left hand side, let's go with Milwaukee. Okay, 600 miles, that is the distance. What is the time? We do not know, so we will set it up as given value t. And the other side, and distance is given 1,100 miles, okay, and to get there we have a longer time, so we will add 1 hour longer, so expression will be t plus 1. For the binomial expression, we always group them and then we do cross multiplication, and we'll find t value, which is the time, okay. When we find this time, what will be the unit for this problem? Is it hour, minute, or seconds? No, obviously hour, right? So let's use hours. All right, let's cross multiply. 600t, distributive property, 600, and 100,000, 1,100 t, and subtract, so that is 500t, which is 600, right? So let's do division. 600 divided by 500, so what do we get? 1.2? Cancel, and then convert, and 12 over 10, so that is 1.2. What's the unit? Hours, that's right. Not miles per hour here. How long here doesn't mean the distance, it means the time, so we use the time as a unit, okay? Hours. In the equation, we use the rate formula because the rates are same, so I need to equate them, okay? Any questions? Next one, number 6. We are going to use Charles' law. Have you heard about Charles' law in science class? Okay, so let's use it, okay? A child went to a winter fair outside and got a balloon at the fair. The temperature outside was 280 degrees Kelvin, which is about 44 degrees Fahrenheit. When a child brought the balloon inside, the temperature increased to 300 degrees Kelvin, which is 8 degrees Fahrenheit. Okay, and then the balloon will increase the size because of the thing inside. So it is 0.5 liter of air. So we will find how much air was there inside from outside. So we are going to use this formula. Formula says ratios are same, okay? So here in the drawing we have outside 208 degrees Kelvin. We use that as a number, so 280 in the denominator, time the temperature, and V stands for the volume, so we have X volume, so we start with the left hand side like that from this quantity. And then this X got a little bigger by 0.5, right? 0.5 getting bigger, so we are adding 0.5 on the unknown quantity. And what was the temperature inside? That was 300 Kelvin. So we solve this and then we can find the answer. So same thing, group the binomial and then use the cross multiplication to solve, and then you can find the answer. All right, let's have a time and then you find the answer and then let's compare it, okay? Okay. So cross multiplication and we can find answer is 7. What's the unit here? Liters. Okay, let me write liters. 7 liters.